It was the year 2030, and 5G wireless technology had become deeply embedded into everyday life around the world. While initial 5G rollouts in the 2020s brought faster download speeds and lower latency, the full potential of 5G was just beginning to be realized with new technological developments and applications. In developed nations, 5G coverage was now nearly universal, and wireless connectivity speeds routinely reached 10 Gbps, fast enough to download an HD movie in under a second. The incredible bandwidth capacity of 5G networks enabled advanced applications like high-definition holographic calls that allowed people to communicate face-to-face from anywhere in the world. Augmented and virtual reality systems were now seamlessly integrated into 5G networks, facilitated by edge computing infrastructure deployed across cities. This allowed for extremely low latency and the ability to support advanced Arkansas VR apps that overlaid digital information onto real-world environments. From virtual tour guides to multiplayer Arkansas gaming arenas, these new 5G-enabled Arkansas VR services were transforming entertainment, travel, education, and more. One of the most impactful 5G innovations was tactile internet technology, which allowed sensations like touch to be transmitted over networks in real time. This enabled advances like remote robotic surgery, where specialist surgeons could operate on patients thousands of miles away by controlling instruments and receiving haptic feedback through 5G connections. The tactile internet was also revolutionizing virtual reality by incorporating touch and motion control into VR experiences. 5G infrastructure enabled massive deployment of internet-connected devices. Cities were now filled with smart vehicles, appliances, environmental sensors, and more, all communicating through 5G networks. With advanced 5G capabilities like network slicing, these diverse technologies were able to operate on the same infrastructure through virtual segregation. Smart cities were now leveraging the influx of big data from 5G-enabled urban tech to monitor traffic patterns, manage public infrastructure, respond to emergencies, and improve civic life. Rural and remote regions once struggling with poor connectivity were now being connected by new 5G satellite networks and wireless mesh systems. Autonomous drones and balloons deployed 5G aerial access points to provide coverage in areas lacking infrastructure. This allowed rural populations access to essential services like telemedicine, education, and e-commerce enabled by 5G capabilities. While the rollout of 5G transformed connectivity in the 2020s, 6G networks began deployment in the late 2020s, promising even greater capacities. With peak speeds of 1 Tbps, 6G enabled more immersive extended reality environments and truly ubiquitous connectivity between people and devices. AI-driven 6G networks used machine learning to dynamically allocate resources, predict network demands, and optimize performance. With the incredibly fast connectivity of 6G, most computation was now done remotely through cloud servers, enabling lightweight Arkansas glasses, flexible devices woven into clothing, and minimally invasive body sensors. 6G also enabled new types of digital interactions called hybrid reality, where augmented overlays could influence physical spaces, like tweaking the temperature, sounds, and lighting of a room. By the early 2030s, first-generation 6G networks were maturing, but the first trial deployments of 7G wireless technology were now emerging in research labs. Early testing showed mind-blowing maximum speeds exceeding 100 Tbps. While 6G focused on connecting people and devices, The vision for 7G was deeper integration between wireless technology and human users. Advanced biosensors allowed 7G networks to collect biodata and understand users' context, emotions, intentions. Bidirectional communications enabled direct sharing of sensations, thoughts, and knowledge between humans and AI. With embedded health sensors, 7G networks monitored users' vital signs in real time and could call for assistance if emergencies arose. The combination of incredibly fast 7G speed and advanced human-to-network interfaces opened up profound possibilities. Experts believed 7G could eventually enable revolutionary applications like seamless high-fidelity brain-computer interfaces and truly immersive hybrid reality environments. Some even envision connecting brains directly to knowledge repositories in real time, eliminating the need for learning. While promising, these visions were far in the future, due to the technical challenges of deploying 7G and maturing the user interface technologies. Still, with each successive wireless generation unlocking new capabilities, the rise of 5G and beyond was driving and accelerating digital transformation. Just as 4G transformed society in the 2010s, the impacts of 5G, 6G, 7G, and future generations on human progress seemed limitless. Subscribe.